Hello everyone, and welcome to today's last webinar of our series Copernicus Marine Essentials. So my name is Gail, and I'm a training officer at Mercator Ocean International, and I'll be one of your hosts for today. So as you know, we add a series of 3 online webinars, and today we will show you how you can use the data for your work. So before we start, we are going to go through some house rules and guidelines to help you follow this webinar in the best possible way. So first, as usual, please do not use the chat that you see on your right-hand side for your questions. You can use it for small talk or say hello to us. But if you have a more technical question or if you have any other type of question, we will use the Q&A section on the website. So on the top bar of your page, you will find the Q&A button. And if you click on it, you will see an area dedicated to the Q&A, and that's where you can ask our speakers the questions you might have today. And as you know, we will have one Q&A session for all the speakers. So if you could write to which speaker your question is for, we would deeply appreciate it. And next to the Q&A section, you will also find a survey about this webinar that you can answer at any time. Another point concerning the Q&A, we will do the same things that we did last time, which is giving you the opportunity to speak directly with our speakers. So to do that, you can use the function raise your hand on Zoom, on the Zoom bottom bar that you will see on your screen. And during the Q&A session, we will give you the microphone for you to discuss with the speakers. So please, we ask you to use this function for relevant questions about the presentations of the Copernicus Marine Service. And we also advise you to put your questions in the Q&A tab I've shown you before. Like that, we can save it for post-event report in case we don't have time to answer the questions today. And now I will give the floor to the second host of today. Welcome, Daria.
Hello, thank you, Gail. So my name is Daria, as I've been already presented, and I will tell you a bit more about this workshop, this webinar, and we will move to practical part. So first of all, some workshop guidelines. These guidelines you can find on the website of this webinar, and also on the website, you have a tab resources in which you can find different useful links to use cases, help center, and other resources you might find interesting and helpful. And yeah, don't hesitate to also check frequently asked question tab as well. And for the speakers today, well, you have me and Gael, as you already know. And our first speaker is Leila Fabre from Mercator Ocean International. She's a user support officer. And then we have Ergan Fouché. She's a PhD student at Mercator Ocean International. And then we have our two use cases presentations. First going to be Chiara Phillips. She is a cartographer and GIS solutions engineer. And the second one is Annunziata Pirro. She's a researcher at National Institute, of Geophysics in Italy. So now we are moving to first presentation, and it's going to be introduction to the user corner and Python-based data manipulation by Leila. And Leila, the floor is all yours.
Hello, everyone. Okay, so today my presentation will be in two parts. So in the first part, I will introduce you to the user corner, which is a place in which you can find various type of information. And then in the next part, we will be working on a notebook together to see how to download data with the toolbox and how to quickly manipulate the data with Python. So let's start. So from the Copernicus Marine Service homepage, you can access the user corner by clicking on this button. So you can see that there are many tabs, and I'm going to present some of them. So the first one is the Help Center. This is where you will find all our articles about our product, product, our services, our tools. You will also find articles that explain how to use the data with in different ways and with different softwares. So if you have a question, I highly recommend you to check the Help Center. Then we have the user notification service. So this is the place that will help you to stay updated on our latest news regarding our products and our services. So we publish general improvement, incident, and maintenance notifications. If you want to learn more about notification, you just have to click on it to read the details. And you also have the possibility to subscribe to the RSS feed so that you can stay updated directly on your email address. Actually, we have an article in the Help Center that explains how to subscribe to the RSS feed. So it is this article. Then there is the e-learning materials tab. So this is where you can find all our tutorials. So there are many of them. They are sorted by the level, the subject, and the tools that are used in the tutorials. Usually a tutorial contains a video and a notebook so that you can replicate the work. In the Get Inspired tab, you have the use cases. So this is pretty interesting if you want to see how our data can be used and what you can observe with the data. And you can filter the use cases by region, country, and markets. And finally, the last tab I wanted to show you is data in a nutshell, because in there you will find this illustration that summarize what kind of data the Copernicus Marine Service delivers. So we provide free and regular data for the blue ocean, which describes the physical state of the ocean with data like the temperature, the salinity, the velocity. We have data for the white ocean, which describes the life cycle of the floating ice with data like the sea ice velocity, the sea ice concentration, and so on. And we have data for the green ocean, which describes the biological and the biogeochemical state of the ocean with data like oxygen, pH, chlorophyll A, and so on. So the data are delivered in the global or the regional scale, and they can come from three different sources: satellite observation, in situ measurements, and ocean numerical model. In the next part of this presentation, we will be working with data that correspond to the blue ocean, and more specifically with wave data. So on the illustration, you can see that the three types of source are available for the wave data, but we will be working with data that come from a numerical model. Okay, sorry, okay. So to access the notebook now, you have to click on Events. Then you click on the current event, Agenda, and the notebook is right here. You have to click here to access it. You will have to write your Copernicus Marine username and password, and you will be in the notebook. So this notebook will stay available even after the event has ended. So I've already opened the notebook. It is right here. So you can see that we are in a Jupyter Lab environment. You need to know that this workspace is temporary. And by that, I mean that if you work on the notebook, if you do some modification, the changes won't be saved, because if your session is inactive for more than 60 minutes, the notebook will be back to its original state. So I recommend, if you want to work on such a notebook and save your work, I recommend you to install Jupyter Lab on your machine. And we have an article in the Help Center that explains how to do that. It is called How to Create a Local Python Environment for Your Copernicus Marine Project. All right, so now let's focus on the notebook. So on the left, you have the file browser. This is where you will find the notebook and also the files you download with the notebook. So you can see that I've already downloaded them. And here you have the table of contents. Okay. So with this notebook, we are going to work on the consequences of the typhoon Haitian that hit Japan in September 2020. So you can see on this My Ocean Pro interface the typhoon just under Japan. So we are going to focus on the impact of the typhoon on the waves. So we have to find the right product. We have to load the data. We are going to do a little bit of manipulation with the data very quickly. And then we will download the data in the NetCDF format and in the CSV format. So the first thing you need to do on a netbook is import the packages that are used, so with this cell, and you also need to authenticate with the login function of the toolbox. So this function was presented to you last time by Anaïs, but just to remind you, this is the function you use to save your username and your password on your machine so that you don't need to write them each time you want to download data. So this is what this cell does. First, it checks whether the current session is authenticated. If it is, nothing happens, but if it is not, you will have to write your username and your password, as I did it here. And then your credential files will be stored. Okay, so to analyze the consequences of the typhoon on the waves, we have to choose the right product. So let's explore the Copernicus Marine Data Store. So on the right, we have all the products, and on the left, the categories with which we can filter the search. So we are going to focus on the blue ocean, more specifically on the waves data. For the area of interest, we don't have a product, a regional product that covers the area around Japan, so I have to select a global ocean product. And for the source of the data, I select numerical model. So the typhoon Haitian hit Japan in September 2020, so we need to make sure that this period would be covered by the product. And now we are down to one product, the Global Ocean Waves Reanalysis. So if I click on it, so first I have a description of the product. And if I go to data access, I have the list of the data sets present in the product. In our case, we will be using this data set because it contains 3 hourly data. So to copy the dataset ID, you just have to click on this button. So back to the notebook, the first thing we need to do to download our data is select the right parameters we need to observe the data. So these are the parameters and they are already set in this cell. So we have the data set that contains the 3 hourly data, the longitude and latitude coordinates that correspond to the area around Japan, the time range. So we are going to observe the data from the 1st of September to the 10th of September 2020. And the variable we are going to download, VHM0, which corresponds to the sea surface wave significant 8. So then we can load the data. So we are loading the data with the open dataset function of the toolbox. So this is a function that is only available with Python. This is why it was not presented to you last time. So with open dataset, you can open the data remotely without having to download them. So it is pretty useful. First, with the cell, we can check the options you can use with open datasets. You just have to write a question mark, call the package, and dot the name of the function. In the output, you can see all the options available with the function. So in this cell, we are using open dataset with the parameters that we have set before to open the data in dataset waves. So the data are right here with the 3 dimensions and the variable downloaded. Now that we have the data loaded, we can do a little bit of manipulation. For example, we can create a map with the XRA package and its cell option. So here we have performed the selection on the time dimension because we are displaying the data for the 4th of September. And we use the method nearest to select the nearest date available in the data and plot to create the map. So we have this map in which we can see the consequence of the typhoon, because under Japan, there are waves that are higher than 12 meters. Okay, now that we have opened the data remotely and that we have done a bit of manipulation, we can download the data. So there are two ways to do that. The first way is by using the XRA package with its to netcdf option. So with this cell, we just have to write the variable in which the data are saved to netcdf and the name of the output file. So I've already downloaded the file. It is right here. The second method you can use to download the data is by using the subset function of the toolbox. So this function was presented to you last time by Anaïs, but on the command line interface. So I wanted to show you the subset function, but with Python, because you will see that the syntax is a bit different. So with this line, we check the options available as we did it before with open datasets. So you can see that there are many options available. And then in this cell, we are running a request to download the data. So this is a subset request, and I understand that writing such a request can be a bit challenging for beginners. So there is an easy way to do that. It is by using the subsetter. So we are going to see that together. So from the data access tab of your product, so we use this data set to access the subsetter. You just have to click on form. And now we are on the subsetter. So just to explain it to you, the subsetter is a tool you can use to download data directly from this page, but there is a size limit. And the subsetter can also be used to create a request automatically for the toolbox. So we are going to do that together just to show you how quick and easy it is. So you have to select, the variable, the area of interest. So the area that surrounds Japan here. And we have to select the time range. So from the 1st of September to the 10th of September. Okay, and once you've selected all the parameters, you just have to click on automate, and you have your request created for the subset function of the toolbox for Python, but also for the command line interface. You just have to copy the request, and then you can paste it on your notebook, and then you will download the data. So we already have the request here, and I've already downloaded it. So you can see that it was successfully downloaded. A name was given to my file, and it is right here. Okay. So now that we have downloaded the data, I just wanted to show you a bit of data processing with the objective in mind to spot the typhoon impacts on the waves. So the first thing you need to do is to open the data we've just downloaded with XRA and its open dataset option. So our data are saved in DS waves. So this first processing you can do is some is to change the time resolution, because since the beginning we've been working with 3 hourly data. So this is a high resolution. It's great, but a high resolution means that you might need a high computers resources and performances. So for some people this can be complicated, and if necessary, this person can decrease the time resolution. So this is what is done in this cell. We are converting the hourly data into daily data, and we save everything in daily subsets. In the next cell, you can see that we are using the daily data to create a map. And now on the map, you can see the evolution of the wave 8 day after day instead of 3 hours after 3 hours. The second thing I wanted to show you is how to find the maximum wave 8. So you can do that with the max option of the X-array package. So the result is right there. You can see that the max wave 8 is a little bit over 13 meters. And we save the result in maximum wave 8. Because we have found this value, we can now find the coordinates and the dates for when it happened. So with this line, we find out that it happened on the 6th of September, 2020. And here we have the geographical coordinates. These coordinates are being saved in these two variables, maxlon and maxlat. Now that we have this information, we can create some graphics. So for example, you can create an interactive time series plot with the hvplot package. So with this package, you can create graphics that will be interactive. For example, we have this line chart. So we can see that for the 6th of September, we have the highest value. If I go on the line, you can see the time is displayed and we have the value. And I said interactive because when I move my mouse over the graphic, I can see the values and the time changing. I can do the same thing, but for a map, an interactive 2D map. Here we have a map that displays the data for the 6th of September. So on the map, I can zoom in, and when I move my mouse, you can see the values. So here I'm over the data. We can see the value, 13 meters, and just under Japan. Okay, and the last thing I wanted to show you in this notebook is another way to open the data with the read data frame function of the toolbox. This function can only be used with Python. And with it, you can open your data remotely directly in a data frame. So it is useful if you want to do some statistics and if you want to download your data in the CSV format. So here we open the data with read data frame with the same parameters as in the beginning. We save everything in data frame waves. And when we open it, we have the data in a data frame. Then we can quickly do some statistics with the describe function of the pandas package. So here you can see the mean value, the minimum value, the maximum value, and so on. And once you're done manipulating the data, you can decide to download them in the CSV format with the to CSV option of the pandas package. And you can see with this line, we are downloading this file, and it is right here. You have to be careful when you download the CSV file because if you download large data, it can exceed your computer's memory and slow down the process. So I'm just going to open the file to show you. So we have the data for the 6th of September. You have the geographical coordinates here, and on the right, the values for each point. Okay, and now I'm done with the notebook. I hope that everything was clear, and if you have a question, I'll be glad to answer it after. Thank you.
Thank you, Leila. And now we are moving to our next presentation, to our next speaker. Do I have a slide? Yeah. Okay, so it's going to be Ergan Fouché, also from Mercator Ocean International. She's a PhD student, and she's going to make do a presentation of Jupyter Notebook exercise. Ergan.
Thank you, Dara. Can you hear me? Yes.
Yes,
Okay.
I can hear you.
Thank you. Okay, so hi everyone, and thank you, Daria, for the introduction. Now that you know everything about how to access the Copernicus Marine Service products, thanks to Leila, I'm going to show you how you can use them in a scientific way to study the ocean physics. The notebook, you can access the notebook here in the event webpage from the Shido section here. And so once you click on this link, you will access this Jupyter lab. So the aim of this notebook is to focus on how you can use Python to display nice plots and to visualize how a cyclone affects the ocean parameters. The first cell here will display you how, shows the effects of the cyclone on the wind and on the waves. So the lines, the white lines show that the winds are converging towards the center of the cyclone, and the colors, so the red colors, show that this has an impact on the waves. The waves are higher, obviously, in the cyclone location. Okay, so we're studying the Shido cyclone. It's a cyclone that occurred in December 2024, and it's been devastating for the Mayotte Island in the Indian Ocean. And so we're going to see how the Copernicus Marine Service products can help us see the evolution and the impacts of the cyclone. To do so, we're going to study three parameters, three physical parameters. So we're going to study the wind, which obviously describes the cyclone. We're going to study the temperature because, as you may know, a cyclone can only occur if the ocean temperature, the surface temperature, is above 27 Celsius degrees. So this is why the temperature of the ocean is an important parameter. And we're going to study the waves because the waves are the consequence of the cyclone, and they have strong impacts on the people and the infrastructures as well. And the last data set, the last data we're going to use is the location of the cyclone. We are going to study the following extent, and we're going to study the dates from December 9th, 2024 to December 15th. Now, about the products we're using, we're going to analyze the wind thanks to satellite observations. We're going to study the temperature thanks to two products, one from a model and another one from satellite observations. And then we'll be able to compare the two products. And finally, we're going to study the waves thanks to numerical models as well. And for each of these three products, you have all the information about the product, all the metadata, and all the information on how to download them. The last thing we're going to use is the location of the cyclone. So this comes from the NOAA website. It's an archive that gathers all the cyclone tracks from the last 3 years. So it's a massive file, but it's very interesting. Now, all the section 3 is talks about how to download the data. So I'm going to skip it because Leila already presented you how it works. And so we're going to dive into the section 4, in which you can see in which we will manipulate the data to display the cyclone effects. The first thing we're doing is to import the Python modules. So we are going to use these libraries that are very basic libraries when you want to display features in Python. So if you want to do plot maps, especially, so you have NumPy, you have Xarray, Matplotlib, and CartoPy. Very basic, again, libraries. And for each of these libraries, you have the link to the documentation. And if you need help on anything, you will probably find the answers on, well, thanks to the documentation. So in this cell, sorry for the light. Okay, sorry. In this cell, we load all the libraries. In section 3, all the products have been downloaded in the data folder here. So I already ran the notebook, and you can see the products are here. And so we will specify the path to the observation. And again, just like Leila showed you before, we open the products thanks to the open dataset function from Xarray. So we have several Python variables. We have the sea surface temperature observation and model. We have the wave model. We have the wind observation, and we have the cyclone tracks. So these are the variables that we're going to work with. If we have a look at how the cyclone tracks file is structured, you can see that it contains many cyclones. So as I said before, all the cyclones from the past 3 years. So we need to select the Shido cyclone, the one we're interested in. And so we did the job and found that the cyclone has this ID. And so in this cell, we're using the where method to keep only the data that refer to the Shido cyclone, so only the data from which the ID of the cyclone is the ID of Shido. That's what we do, and we can see that now we only have one, the data from only one cyclone. Another pre-processing thing we need to do is to compute the wind speed, because the wind observations we have contains the eastward and northward components of the wind, but we need to compute the wind speed, so taking the square root of the two components. And this is what we do here. We take the NumPy square root of the square wind, eastward wind, and the square northward wind. And this gives us a new Python variable that's called full wind speed. And this is what we're going to use. We also need to interpolate this wind at the exact location of the cyclone. So this is what we do now. We are using the interp. Again, it's an Xarray function, interp method, and we specify the longitude, the latitude, and time of the cyclone, and we take the locations and times of the cyclone from the cyclone track variable. Now we are all set to plot our first map, and we are going to plot how the wind has evolved during the Shido cyclone period. So to do so, I'm going to dezoom a little to show you just the result map that we want to do. So this is the map that we want to have. We want a map of the region with the longitude and latitude displayed. We want the coastline to appear. We want to display the wind in the background with a color bar and a label to the color bar. And we want to see where the Shido cyclone is located. So this is what we want to do. And now I'm going to show you in detail how it works. So the first thing we're doing here is that we take a random time step in the cyclone track. So here we take time step number 20, and we select the wind map at the time that we randomly selected. To select the time, we're using the .cell function. Then we can initialize the figure, so we can define the size of the figure, and we can define the projection of the map. Again, if you want to change projection in the Cartopy documentation, you have all the information you need. Then we set the extent, so with the minimum and maximum latitude and longitude. We set the extent, we add the coastline, and we add the land. We display the grid lines, so these are the lines that display the longitude and latitude, and we don't want the labels on the top and on the right. If you have a look here, we have no labels on the top and on the right. We do not need them. And now we can display the wind speed, and we're using the pcolor mesh function. It's a function from Matplotlib. And so we set the longitude, latitude, and the wind. We ask to have a color map in blue, and we set the minimum and maximum values of the map. Now we want to add the cyclone location, so we use the scatter function now. We set the longitude, latitude, the size of the dot, and the color of the dot. And finally, we add the name Shido to see the name of the cyclone. We add the color bar. We set the label of the color bar, and we set the title with the size of the title. And then we can show. And so this is the resulting figure. What we want to do next, so this map has been created for one random daytime, but we want to do it for all the daytimes that we have access to. And so thanks to this, we will create an animation to see how the ocean evolved with Shido. We have created a small function because to automate these maps. So this is what we do here, and all the figures, the resulting figure, are saved in the out folder. And here is the resulting animation. You can see that Shido is going westward, and that along Shido track, the wind is strong, obviously. This is the first map that we wanted to plot. We can see how the wind changed with Shido. Now we're moving on to the second figures that we want to see, and we want now to see the effects on waves. We are using the wave model that we set before, and we are using the variable VHMO. And again, we will plot a first map and then an animation. Just like before, I'm presenting you the resulting figure. So it's basically the same as the previous figure, except that on the left, we want to display the wind that we just computed before of, the wind below Shido track. So here is how we do. So again, we select a random time. We select the wave model at the time that we set. We initialize the figure. We define the extent, the coastline, and the land features of the map. We add the grid lines. With P-color mesh, we add the background colors, so the wave height. And then we use now the scatter plot, just like we did before, to display the location of the cyclone, but we add a C parameter, which means that we want the color of the location of the plot to refer to the winds that we computed. Again, we add the location of the cyclone, the final location of the cyclone, and the text. We add the two color bars, so one on the left for the wind and one on the right for the waves. We set the title and we show. So this is what we get in the end. And just like for the wind, we can have an animation. And we can see that just like for the wind, with the waves, they are also affected. They are also affected with the Shido cyclone, and we can see that the waves are reaching 5 meters at least around the cyclone. The last thing we want to study is the effect of the cyclone on sea surface temperature. So as I said in the beginning, we're comparing two products. So one product from satellite observations and one product from ocean model. We can see how these two products are structured. So for the model product, we will use the θO variable. And for the sea surface temperature in the observations, we will use the analyzed SST variable. again, a first view of the resulting figures. So we want to have now two figures side by side. So on the left, we want to display the model temperature, and on the right, we want the satellite, the SST from satellites. And we want to have two color bars. We also want to display the wind along shadow, just like we did before. And that's it. So it's basically the same as we did before. So again, we take a random time step. We select the two products, so the model and the observed products at the time of the cyclone. For the model, as we can see before, the model contains many depths. Well, may contain many depths. So we make sure that we take the surface, so the depth that's closest to 0. Then we initialize the figure. We are using a different function now because we want two subplots. So we want one on the left and one on the right, and we set this with the add subplot method. For each of the axes, we do just like we did before. So we set the extent, we add the coastlines, we add the land features, the grid lines, etc. We're setting the color map. So here it's plasma for the surface temperature. And again, we're using p-color mesh on the two sides to display the temperature. We add, just like we did before, the scatter plot of the cyclone tracks that refers with the color that refers to the wind. And then we add the two color bars, and then we add the title. And so this is the resulting map. From this map, we can see that the model and the observed SST are pretty much alike. So we can see differences. The first difference is the resolution of the product. So the model details more finely the ocean features, but otherwise it's pretty much alike. And again, just like before, we are creating plenty of images, and we are creating an animation from them. And so this is the result. And so what we can see, as I said before, a cyclone can only develop if the ocean temperature is above 27 degrees. So we can see that it's the case, especially around Mayotte. The ocean in December was pretty hot. And so this is why the cyclone had so much energy. We can also see that when the cyclone evolves, the ocean temperature decreases. So the cyclone cools the ocean. And so that's what we can see from this map. And this was our last animation, the last thing we wanted to analyze. An exercise we propose for you is to find another cyclone, something maybe that occurred in your region or more recent cyclone, and to try to reproduce all these notebooks, so download the data and plot all the maps and animations. And that's the end of this notebook. That's the end of our presentation. And if you have questions, we will answer in the end of the.
Thank you again. It was very interesting. I hope our participants learned something new. And now we'll move to our use panel discussion. And well, this use panel discussion is going to be basically a short presentation of each of our speaker about their work, and then we're going to have discussion with them with questions we prepared to them, and then of course the Q&A session as it been already announced. So first is Chiara Phillips. Chiara, you can start sharing your screen. We see it, but we don't hear you. You are mute.
Oh, good. Okay, I think you should hear me now.
Yeah, it's all good. Yeah.
Great. Cool. So I'll begin. So hi, everyone. My name's Chiara Phillips, and I'm a freelance cartographer and data visualization designer. So I really specialize in helping people connect with environmental data through maps and visuals. And a bit more on my background, I graduated from UCLA with a degree in geography and environmental studies with minors in food studies and geospatial information systems and technologies. And in my career since, I've worked with organizations such as NASA Develop and the USDA Foreign Agricultural Service to apply geospatial tools to address different challenges in agriculture, land management, and food security. And I'm currently working as a senior solutions engineer for a climate tech startup in Berlin called Sakana, where I use GIS, remote sensing, and machine learning to monitor carbon sequestration. And as a cartographer, my work really blends science, design, and communication to make complex geospatial data sets meaningful to a broader audience. So often when I tell people that I'm a cartographer, one of the most common questions that I get back is, haven't we mapped everything already? But the truth is that the world is constantly in a state of flux. So borders are changing all the time, epidemics break out, seas rise, storms pop up, and we really need cartographers to make that geospatial data visible and understandable and actionable for a broader audience. And they say that you can't change what you can't see, and maps really help us see things. They help us see patterns from the past and learn from our successes or mistakes that we've made. They can help us predict the future and uncover potential outcomes of our actions. And they can also help us make better informed decisions or change how we see the world. And lastly, they can also inspire us. And I think that shouldn't be underestimated, the power of inspiration. It can be a very powerful force. And despite maps being so important in our lives and like such a huge part of our lives, I've often felt that the decisions that go behind making them are not as well known to broader audiences. So last month, as part of my keynote presentation within the Copernicus Marine Service DataViz webinar series, I delivered a talk on my approach to cartography and how I applied it using Copernicus Marine Service data. And I did this through creating a mnemonic called AED, which stands for Audience Ethics and Design. And it's inspired by this medical device that some of you may have already known called AED, which basically analyzes someone's heart rhythm and delivers a shock to help get it back beating effectively in medical situations. And in the same way, in cartography, we can use AED principles of audience ethics and design to make sure that our map functions effectively for the people that need to use it. So whenever I begin a map, I first think about the audience. So I think about who are they, how will they be viewing it, what's their background, why might they be using my map or looking at it. And so when I created my North Atlantic spring phytoplankton bloom map, I knew that my primary audience would be current or aspiring data visualization professionals. And I wasn't expecting them to necessarily have as deep of a background in ocean science. So I needed to have perhaps more context about that in my visualization. And I also knew that it'd be shown in a webinar. So everything really needed to be understandable at a glance, and I'd be working with slide dimensions. And basically thinking about these things really helped me shape the goal of my map from the start, which ended up being to make, this North Atlantic spring phytoplankton bloom phenomenon really engaging and easy to understand while I was also teaching cartography through it. And the next letter in our mnemonic AED is E for ethics. So I also talked about how map makers really have a huge responsibility to manage because people place a lot of trust into maps. So we have to make sure that we represent our data accurately and clearly and are very intentional about our design choices so that we can communicate to our map viewers effectively. So for me, this meant that I had the responsibility to learn about phytoplankton and about the spring phytoplankton bloom so I wouldn't mislead my audience. And so I did a lot of research on my own and also got to meet with another ocean scientist. So I could learn more about like what the definition of a bloom was, what concentrations we generally see, and how it's typically visualized, or if the phenomenon was good, bad, or neutral. And I also wanted to make sure that my process was reproducible and transparent and that other cartography professionals would approve of what I'm doing. So this, for me, was all part of the ethics part of designing here. And then lastly, but not least, is design. So we really need to think about how we can make it easy for our audience to understand what we're trying to say, because basically not all elements of a map are equally important. So we have to make sure that the most critical information stands out first and really consider color, composition, size, and white space, both for what we see with our own eye, but then also making sure that our designs are as accessible as possible to any viewers outside of ourselves as well. And here's the actual phytoplankton bloom map that I made using Copernicus Marine Service data. And basically I adapted it many times iteratively, going through like the different AED principles and also asking real people for feedback and asking them what they noticed first or what questions they had or what their biggest takeaway was from the map. And then the last thing that I stressed to my audience was to be patient with yourself, to allow yourself to try new things and to have the courage to try again when things don't exactly work out, and to not judge the beginning of your map or your journey with someone else's final piece, because it's all a process and there's so much that you can learn along the way. And yeah, I think for cartographers like me or future cartographers, I think the Copernicus Marine Service data opens up a lot of exciting possibilities because it's free. There's tons of great ocean data sets to explore, and the user support and documentation is really thorough. And I think if you both have access to this data and the knowledge to consider your audience and cartographic ethics and design principles, you can really create effective maps that help inform decisions, increase awareness, monitor change, and inspire people and spark curiosity about our world. And I also really wanted to lower the barriers for people that were new to this data, or show that you don't need to really be a developer or a scientist to start making your own marine visualizations. So for you to get started and try creating the map that I did, I've also created a few resources with several tutorials on how to access, download, process, and visualize the data from the Copernicus Marine Service for this plankton map in particular. So you can feel free to check it out on YouTube. And if you do try any parts of that workflow, I'd love to see what you create. So yeah, feel free to share it with me, and my socials are linked on here. So thanks so much. And I hope you feel inspired to explore the Copernicus Marine Service platform and all the incredible data it has to offer.
Thank you, Chiara. It was really, really interesting. And well, we for sure will have more questions for you, but first we're gonna listen to the presentation of Annunziata. Annunziata, you can start.
Can you hear me?
Yes,
Yeah.
we can.
Okay, let me share the screen. There you go.
Yeah, we see it.
Okay, perfect. Okay, so hi everyone. So my name is Annunziata Pirro. I'm a researcher at OGS in Trieste, Italy, and I own a PhD in physical oceanography from University of Notre Dame in Indiana in the USA. And after my graduation, I joined the OGS with a postdoc position, and now I'm a permanent researcher here. Today I'm going to show you about the ocean dynamics, a multidisciplinary approach. So something of my research, what I do. So what I do, I study the ocean mainly with in situ data, and in particular with the glider and floats, and all these data are corroborated, supported by the Copernicus Marine Service data. So for people that don't know, glider is an autonomous system that you can see here from your left, and the glider move up and down in the water column, collecting physical and biochemical property, and when it at the surface, it transmitted the data and take the comment. While the floats, like you can see from this picture here, is a buoy that is released from the boat. It sinks up to a depth of 1,000 meters, drift with the ocean current, and then sink again up to 2,000 meters. And while it rises to the surface, it collects again physical and biogeochemical properties of the ocean, and then transmit the data through the satellite. So I mainly work in the Mediterranean area, so Adriatic, Ionian, and Levantine basin, and in the Antarctic. And my research focuses on the water masses transformation, on circulation of the ocean, on the ocean dynamics, and in particular on the physical processes that are behind these ocean dynamics. Today I'm gonna show you a little bit of the science that I do, and in particular the circulation dynamics in the Mediterranean Sea, in the Levantine basin. We're gonna see how this wave driven by the mid-Mediterranean jet forms, and how this eddy, the Cyprus eddy, and this SSE and NSE eddy form, and why the center of this eddy sometimes shift to the east or to the west. Starting from in situ data. So my colleague back in 2016 had some glider campaign, field campaign south of the island of Cyprus. So Cyprus is this here. And with the glider, they were able to detect the Cyprus eddy, which is this anticyclonic eddy here in red here. And you can see from temperature and salinity section how the glider was able to detect with high resolution space and time the Cyprus eddy, the SSE, and not the only these two, not the NSE. And if we zoom in, we see that the glider, you see, give high resolution up to 800 meter depth. And these are on your right side, the glider section that you can see. This is big Cyprus eddy. So what are these my scientific question? How does this Cyprus eddy form? Why this eddy, the center of this eddy sometimes shift to the right and to the left, and how the eddy G1 and G2 form, these guys over here? So starting from the in situ data, I recalled that south of the Cyprus eddy, there is an Eratosthenes seamount. The section is right here. And then I start to look at the theory. I asked to myself, is there a mathematical formula that already simulate my problem? Yes, the answer is yes. In 1975, McCartney, he simulated a flow coming from the west, impinging over seamount, and generates this wave, nice waves, and nice eddy. He simulated the ocean with the two layer, upper layer, lower layer, with a circular sea mountain, incoming sea flow, U1, U2. He had a bunch of non-dimensional parameters like Rossby number, stratification, height of the sea mountain, and then simulated the ocean with homogeneous and stratified case. And what he realized that in the case of strong stratified ocean, so when the density is very different from each layer, he got the presence of these nice Rossby waves, nice eddy above the sea mountain or behind the sea mountain, only if the ratio H0 over epsilon is very high. And this ratio is a non-dimensional parameter that takes care of the incoming velocity. So the incoming velocity is the key element that generates you these nice waves and nice eddy. So what I did, I took the absolute dynamic topography of 20 years of data from Copernicus Marine Service. We constructed an algorithm, and we realized that there you go. So we realized that when the Cyprus eddy is formed, which is this red guy here, it's west of the sea mountain. The sea mountain is this white dot here. There is space for the formation of the other anticyclonic eddy, the North Shikmona eddy and the small South Shikmona eddy. Instead, when the Cyprus eddy it forms east of the Eratosthenes sea mountain, there is no space for the wave to develop because there is the Lebanon boundary current here. So, as I said, the velocity is important. So what I did at this section, I took the incoming velocity that simulated the mid-Mediterranean jet, and I correlated with the center of the Cyprus eddy, the center detected with the algorithm from Aditi, and I realized that when the velocity increased, so the mid-Mediterranean jet increased, the Cyprus eddy started to move to the west. When the mid-Mediterranean jet decreased, the Cyprus eddy moves to the east. And you have this nice shifting of the center. And the two eddy, the South Shikmona eddy and North Shikmona eddy, which are red and blue crosses here, they appear at the same time. So everything was nicely correlated. But then I did a step a bit further, and then I asked to myself, where this velocity come from? It's driven by the North Ionian gyre, which is this eddy right here in in the Ionian Sea that sometimes spins in a cyclonic way or anticyclonic way. I computed the vorticity from the geostrophic velocity of 20 years time series and correlated with center of the Cyprus eddy, and I realized that when this North Ionian gyre switched from anticyclonic to cyclonic phase, because the vorticity from negative steps to positive, then the gyre, the Cyprus eddy, start to move to the west. And then again, when the vorticity switched from cyclonic to anticyclonic eddy, then the gyre moved to the opposite direction. And again in 20 years, and everything has an effect of after 3 years. So whatever happens to the North Ionian gyre, his vorticity, the wave of his spinning regulate the flux through the mid-Mediterranean jet, which generated these waves and this eddy. Last but not least, I simulated this phenomenon in a rotating tank in the Lecce laboratory in Grenoble. So as you can see here, we simulated the Eratosthenes Sea mountain. We had a sloping bottom, an incoming flow, and we used the in situ data to simulate this phenomenon, so the real data. And as you can see from this picture, we had this wave here, nice wave yellow. The Eratosthenes Sea mountain is the white area here with the formation of the Cyprus eddy above the Eratosthenes, and then the two eddies, South Shikmona and North Shikmona. And here on your right, you can see a field velocity that it's in agreement with the simulation. So this is a bit of my science that show you how I integrated the different data set from in situ, Copernicus, or laboratory experiment, and this is my take-home message. So in situ data provide high resolution data. If you consider that glider, for example, have a horizontal resolution of 3 kilometers and give you data every 5 minutes, for example, or every 1 meter of depth, and collect the data in 1000 meters along all the water column, but they cannot cover larger area. So Copernicus data are very useful because provide a big picture of the phenomena that you want to study, and then theoretical arguments and lab experiment, they support even further the hypothesis that you may have. So thank you so much.
Thank you. Thank you. It was a very nice presentation. So now we are moving to our use panel discussion. We will have some questions for you on the slides that are coming. Yeah, great. You just see the timer. Yes, great. Thank you. So we will have some questions, and since you're coming from very different background, we find it's going to be an interesting discussion. And we also have questions that are the common questions for both of you, and also separate questions for each of you. So we start with the first one for both of you. And what would you say are the main advantages of using open free Earth observation data for your kind of work? So Chiara, Annunziata, I don't know who wants to start, but well, it's up to you.
You can start. I mean, or if you, Chiara, you want to start? No, okay. So yeah, I can say the advantages, of course, they are free. You have a cost saving, and you can have a long monitoring time series. You can cover a larger area, like already Chiara said in her presentation. But I want to add two things. The first is that this Copernicus data give an educational opportunity, because student, early career researcher, or simply educator, they can hone and build their skill, using real data, high resolution real data. And last, we don't have to forget that Copernicus Marine Service data are based on the principle of truth and trust, so which is very important when monitoring the environment.
Yeah,
Okay,
and I think
Chiara?
For me, I totally want to echo everything she said. I mean, I think the main advantages I see for my field of work for using open and free Earth observation data like this are first for reproducibility. So, I mean, if you use and cite your data clearly, other people can really reproduce your work. And I feel like that transparency is really important in science communication and design. And then, yeah, I want to echo just like that accessibility. So it being open and free, I think just more people of all different specialties and backgrounds will have access to it who might not have been able to access that data otherwise. And I think it just lends itself to new ideas, more perspectives, and more collaboration. And then, yeah, I think the last thing is, yeah, also that education piece and just this idea of like relationship building with our ocean. So I think the more you have access to this data and the more that people engage with it, the more that people like, yeah, have a relationship with our world, with our oceans and learn about it. And I think when you learn about things, you can grow to love it. And when you love things, you can protect it. And so I think it can have a really great impact on our relationships to the world and decision making and informing us.
Okay, thank you. Annunziata, you have something to add or?
No, that's
okay.
Yeah.
Okay, great. Then the next question. If you had to describe a Copernicus Mirror service in one sentence to someone new to it, what would you say? A bit of creativity in this question.
That's fantastic. Please use it. I mean, it's very useful. It has a variety of products from physical, biogeochemical, as I showed you, and you can integrate with your in situ data or with whatever other data set that you can have and try to compare and match and see the differences. Also in resolution, the resolution is very important. So if it's a final resolution, for example, with glider data, you have a final resolution, so you can see something very in detail, but with Copernicus marine data, you can have a larger perspective, a big picture. And they are important because they can support not only research, but also policy and policymaker and industry. So I think this is really great point that you guys can have.
Yeah, and I think for me, yeah, it's hard to put it in one sentence, but yeah, I would say that it's a free data platform that hosts ocean data like sea surface temperature, ice, phytoplankton concentrations that anyone can feel free to explore and use.
Okay, thank you. Yeah, it's true that this service is quite vast to just include its explanation and its promotion in one sentence. So next question is actually two questions, which are separate questions for both of you. So first is a question to Chiara. What kinds of tools or programming languages do you use most when working with this data for visualization?
Yeah, I would say in terms of programming languages, I use Python the most for data processing and cleaning and pulling from sites such as Copernicus Marine Service. And then, yeah, I sometimes am using charting, websites like Data Wrapper. And then, yeah, in terms of like GIS software, I'm often using QGIS, but I also use ArcGIS Pro sometimes. And then if I also want to go the step further and use more graphic design software, I'll use Adobe Illustrator, Premiere, also Canva sometimes, or even Google Slides in terms of like work situations so that people can edit any of the labels from their own computers as well.
Okay. Okay, and for you, Annunziata, the question is, can you elaborate on how you validated the data or integrated it into your scientific workflow?
Yeah, for the validation and integration, I didn't show you in my presentation, but when I chose the section where I computed the velocity, I had the incoming velocity from the in situ data, of course, but it was very short period. Probably it was 1 month, probably, or even 2, but not even more than 2 months. So it was not enough to cover the 20 years of data. So I correlated the velocity from in situ velocity with the Copernicus marine data. And I saw that they were very highly correlated a little bit underestimated the Copernicus data. So it was safe for me to consider all the 20 years data set from Copernicus data. And the same from the center of the Cyprus Eddy. I computed from the glider track using a salinity criterion, and I had only 20 points of center of the eddy, and then I correlated again with the center computed from the algorithm of from the ADT absolute dynamic topography, and they match really well. So it's kind of safe for me to use again all the 20 years of data.
Okay. We can move for next question, I think. So again, separated questions. First for Chiara is, could you describe your creative process when creating a visualization using real data?
Yeah, sure. I mean, I think my creative process, I guess it's not really unique to me. I think a lot of creatives follow this similar thing, but basically my creative process starts and ends with rest. So it looks like living my life, looking at art, getting outside, watching movies, talking to people, reading things, and just generally doing things that are relaxing and nurturing to my inner artist. And then in that process, I think sometimes you'll spark an idea, or perhaps you'll come across a data set that you want to explore, or a combination of both. And then from there, I kind of think about the AED principles, and I actually schedule time to sit down and work on something creative. Because I think a lot of times people can feel like, oh, this creative thing, it'll just happen magically. Like sometimes I'll just get the motivation to do it. But I think it's really a matter of just sitting down, blocking some time and working on it. And then, yeah, as I'm working on it, then I go through and iterate and improve it. And lastly, share it with others. And then I start the cycle again and go back to resting and taking in inspiration from the world again.
Okay, thank you. And for you, Annunziata, maybe you have some experience also with you know, a creative process, because all research is also a creative process. So maybe you have something to say for this.
Oh yeah, creative process. It's more scientific. I mean, it's more hard for scientific. It's a matter of what you want to show. Sometimes, I mean. To find the best way to communicate your science. It seems that it's easier, but it's not. Sometimes even a different color map can show you something that you really want to show. So for me, for example, it takes time to understand your science, but it takes time even more to show what you really want to show and to help people to understand. So sometimes I sit in my office or really at home when I am alone, or at night before sleeping, I try to think how to really show my science to be more communicative as possible.
Yeah, okay, yeah, I think, yeah, exactly. Because, well, especially when you're a researcher and when you do the same thing for a very long time, you might not exactly see, but this data, well, it tells something to you, but maybe to someone else it won't. So you really need to think, to put yourself in someone else's shoes to see how it's exactly going to be taken.
Yeah, because as a scientist, you are used to see always the same thing. For you, is kind of normal, you know, to see always the temperature in the jar. For you, it's normal, but you have to think that your paper can be read by also another person that is not an oceanographer. So you have to be as much clear as possible. And even when I say to the PhD student or people that just are just at the beginning, even the caption of the figure is very, very important, because sometimes people are lazy when they read the paper. They could just read the abstract, the discussion, or the conclusion, and the figures. So from the figures, they want to understand all the paper. So the visualization is important, and the caption, really, you have to write what you want to say.
Yeah, okay, thank you. And well, you still have one question for you.
Okay.
How does your academic research benefit from operational data sources like Copernicus, as opposed to traditional in situ methods?
Yeah, I can say the OGS has a huge benefit in different ways. So here at OGS we have different group. For example, we have the modeling group. They use this data to constrain the model simulation because in situ data are sparse and not enough. So for the constraining, for the boundary condition of the model simulation, I can say, but for the physical oceanography group where I work with, they are useful because you can observe the phenomenon that you observe with in situ data here in the present. You are able to observe with Copernicus data in the past. And for probably in a different area, if the physical mechanism is the same, you can observe the same phenomenon in a really different area, for example, in the Antarctica and not in the Mediterranean Sea. And the last thing I want to say, we mainly work with the water masses transformation. We mainly work also for dense water formation. So the chlorophyll data are very important. We use the chlorophyll at the surface, the non-processed data, to highlight the upwelling area. And so the chlorophyll is a proxy for nutrient. So when you have this upwelling area, you expect more nutrient and so more chlorophyll. So that's when I say the three main things that our OGS benefits from the Copernicus data.
Okay, yeah, thank you. That was a very thorough answer. So for now, we finished with the questions with a panel discussion, and I think we can move straight to the Q&A session, so our participants can have more time to also exchange with you. And Gael, you want to introduce?
Yeah. So thanks again, Chiara and Annunziata, for your presentation. And so as Daria said, we will now move to the Q&A session with all of the speakers, and we will start by dedicating the first part to people who have raised their hand on Slido. And for the second part, we will go to the Q&A tab for the written questions. So yeah, and also don't hesitate to ask your question in Slido in case we don't have time to do them. We will provide later the answer in the post-event report. Okay, so also, just as a reminder, if people leave during the Q&A session, replays, presentations, and certificate of attendance will be made available in the few hours. And you can also take a look at the polls of the webinar series. That would be deeply appreciated. Okay, so now we will go to the Q&A part with the microphone on, and I apologize in advance if I mispronounce the name of the people who will ask the questions. Okay, so I will start with Dr. Eira Petillon-Avetic. You should be able to speak. You just have to unmute yourself before asking the question.
Okay, I have used Copernicus data for comparison, and I'm very thankful to that one. And if also I get the notebooks downloaded, then it will be nice, and I will access later on. Thank you very much.
Okay, yeah, the tutorials of today are available on the website, so you can have a look, and we will also put back the link for you in the chat. No worries. Thanks.
Thank you.
Okay, so I will go to the next person. So this time it's Albert. It's written at once, so I don't know how to pronounce it, but you should be able to speak, and yeah, you just have to unmute yourself also to ask the question. I don't. Okay, so, well, okay, so I don't know if the person is still in front of the screen, so I will just I will select someone else in the meantime. Okay, so the next person should be Abiola Agonchim. You should be able to ask the questions. Hi.
Yes, this is Abiola Anyoncheme. Yes, my name is Abiola Anyoncheme. You are pronouncing this name very well. I'm very happy to be on this platform and this webinar. I really appreciate how best Copernicus is is managing the blue economy data. My question is to know what politics are you implementing to extend such knowledge over West African countries. You know, we have coastal areas where a lot of issue is going there, like for example, marine pollutions and so on. That said, you know, the data is critical in these regions. So how can you manage so that as a scientist, we may be able to spray the new knowledge you are now making available for the planet?
Okay.
That is my question.
Okay, I think I can answer at least some part of it. So as you know, we have data all around the globe. So obviously around Africa also, we have a few use cases of the data used around Africa. And we can put the link for you in the chat of the session. Mercator Ocean is managing a new project called Opera. So it's a big project, and it includes the African region with capacity development specific activities specifically designed for the African communities. So we can put the link in the chat for you to have a look, and I guess it can help you with your work, or if you, I don't know if you have students, or just help them to use the data and, well, to study some issues that the African region can face in oceanography. So we will put the link in the chat for you, and you can have a better look at all of the details about that.
Okay, that is wonderful, because you know, the people are less accommodated with the cloud data, which is very, very the best one. Because you know, me for my thesis, I use TRM data, and then I correlated with the institute data. Then I found it a very, very, very good measurement. It's close. It's almost 98% reliable. So I think if we could make people know more that using cloud data could help to save costs in data collection, and also make things available for academic purpose. So that is a wonderful tools, by the way. So we want to expand, we want to popularize this so that people may know, yes, there is easy way to manage data, and we don't want to continue with the cost to spend more money going to the field and collect data, and then we come to the office. Now we have an issue to analyze. So thank you so much. I will appreciate that you put that link, or maybe share with me. Then I will spray within my network. Thank you so much.
Thank you. Thank you. The link is in the chat already, so you can have a look. Thanks. Okay. So I will go to the next person. Okay, sorry. Okay, so the next person should be Sambu Bilali. You should be able to speak if you turn on your microphone and ask your question. Okay. So if nothing is happening, oh, yeah.
Hello, good morning.
Hi. Hi.
Thank you for your presentation. My name is Sambu Bilali in Benin.
I'm sorry, we can't hear you well. So maybe for your questions, I don't know if you have another microphone, or you can put the question in written form on the Q&A tab, because we don't hear you. There is a background noise.
Okay, my name is Sambu Bilali. I'm from Benin.
Yeah, it's better now.
Yes. So my question is, Are there any pilot projects in Africa using Copernicus marine data to monitor coastal erosion? No.
On the specific topic, I'm not sure. I won't be able to answer, but as we said before with the precedent people, there is a big project organized by Mercator Ocean that goes on the African oceanographic issues that it can face. So maybe you can have a look on this link. So it's called the Ocean Predict Opera Ocean Prediction Project. And I think they have all the list of the specific topics they want to study. So maybe you will find something that can match there.
Okay. So my second question.
Yeah.
Are there any pilot projects in Africa using Copernicus marine data to monitor coastal erosion? No, this is no.
Yeah, so that's the answer I was saying about the Opera project. So it's about African issues and its oceanographical region. So you can have a look at this project. We put the link in the chat, and I think everything is detailed on there. So you can have a look about your region you want to study.
Okay. Okay, it's good.
Thank you. Okay. Okay, so next person. Sorry. Wait, sorry, I lost the window. Okay. So the next people who should be able to speak is Dr. Shiva Kumar Magada. So if you want to ask your questions, you are now allowed to talk. I see you unmute, but we can't hear you for now.
Namaste. Am I audible
Hi.
now?
Yeah, we can hear you.
Namaste from India. I am Dr. Shivakumar Magada, Professor of Aquatic Biology for last 3 decades. Recently, we have established Arabian Sea Fisheries Management Coordination Committee. In short, it is called C equals MC square. All the professionals from India and other 6 countries surrounding the Arabian Sea. We wish to collaborate with Copernicus and such other organizations involved in these issues. Thank you. It was a wonderful session. I'm very happy to be part of this webinar. Take my compliments from me and from Institute.
Okay, well, thanks a lot, and we are happy that you enjoyed the session. For the collaboration, we can have a look on our side with Mercator Ocean if people are interested, and we will let you know in the post-event report if something is opening for this opportunity.
Thank you very much.
Okay. Okay, so someone else. We have a few hands still raised, so I think we will be on that part for a while. The next speaker participant would be Belo Sahid. So, hi, you should be able to speak if you unmute yourself and ask your question.
Yeah, good morning, everyone.
Hi.
Yeah, good morning. Can you hear me?
Yeah, we can hear you.
Yeah, my name is Belo Sahid. I'm from Ghana, but live in Germany here. I'm a marine engineer by profession from Ukraine, but living in Germany here. Now, this is my second time on this meeting, and I want to go back to question 2. The second question you asked when you're asking the speaker when they are talking. But
Yeah,
I'm new.
And
I want maritime innovation for my career.
Can you just repeat the question? You want to exchange with Annunziata and Chiara about the second questions they were asked? That's right?
Yeah. The second question you asked, that if you want to present Copernicus maritime service to somebody that is new, what can you say? And as a marine engineer that work in engine room, I want to know more how I can benefit from it.
So we also have other events called training where we present, well, it's on specific regions or topics, and it's more detailed sessions on today where we have use cases presentation of guest speakers like Annunziata and Chiara, and we also make tutorials for these type of sessions. So it's tutorials in Jupyter Notebooks, QGIS, and RStudio. So it can give you more examples on what you can do with the data if you are a beginner yourself. There is also on the website a catalog with past tutorials or other use cases that are not necessarily shown during the event. So it can give you some ideas on what you can do with the data and how you can use it. So we can also put the link of these pages on the chat. And yeah, maybe it can just, as a beginner, help you manipulate the data. We also have articles on the tools of the Copernicus Marine Service. So yeah, I think that's a good start for a beginner who doesn't know how to use the Copernicus Marine Service. And we also have the replays of this webinar series with all of the tools that have been presented. So
okay, thank you.
You're welcome. So we will put the links in the chat right away. Okay. Okay, so we still have a few raised hands. So yeah, for the question, if you can have the question also for some of the speakers, it would be great. Okay, so I have now it should be the turn of Jacob Frederiksen. You should be able to speak. You are on mute, but we can't hear you for now. Okay. Well, I think I will go to someone else because we can't hear anything for now. Oh, okay, so I will do one last person, I think. Okay. Okay, so now it should be the turn of Benson. You should be able to ask your question.
Thank you very much. I want to extend my very honest and sincere commendation to the Copernicus team. Mine is not a question. I want to thank you for the wonderful lectures that we've received. I attended the first day, the second day, and of course, today again. The challenge, which I would say I've observed, is that, of course, I joined through the Zoom, and the chat here in Zoom is disabled. So when you talk about sharing the links, excuse me, please, definitely we don't see it here. So I don't know whether it will be possible for you to share, probably copy the links, and of course maybe share to us when you send your emails finally to us. Yeah, so please, because I don't get to see the links.
Yeah, so the chat, it's not the Zoom chat, is the chat on the web page of the event where you have all of the agenda, the speakers, the replays and everything. So it's not directly on Zoom, but we also provide the Zoom link in case you have some technical issues while trying to join on the web page of the event. But we will put all of the links on the post-event report, and you will be made aware of the availability by email. So no worries about that.
Thank you so much for that.
Okay, thanks. Okay. We still have a few, and okay, I will just try one more person because I think the hands I still have didn't answer when we allowed them to speak. Okay, so the last one, it should be, so Inacio Bonda, you should be able to ask your question. if you unmute yourself. Okay. Okay. Well, I think you're still mute, so I don't know, but I think we will go to the Q&A session on Slido with the written question to be able to do some more questions for the speakers and just in general the questions people ask in the chat. So, okay. Okay, yeah, we can go on Slido for the written question. Thanks, everyone. Okay, so it will appear in a few seconds. And yes, so for the people who raised their hand and weren't able to speak, you can put your question on Slido. We will answer them today or on the post-event report, as usual. Oh, okay. Okay, thanks.
Okay, so here are questions. Well, let's start. And the first one is for Leila. Does using open dataset function without downloading the data locally have any drawbacks like performance or latency issues?
Okay. The open dataset function doesn't have any drawbacks. Actually, it is pretty fast if you have a good computer and a good connection. But if you use it right now, you need to know that there is an incident. So it might be a bit slow, but the incident will be resolved very soon. So when it will be resolved, so you can check that in the user notification service that I showed in my presentation. So when it is resolved, I recommend you to use the open dataset function, and you will see that yeah, it is its performance is good. It's not slow.
Okay. Okay. Next question is to Annunziata. What are the tools and techniques to measure wave velocity? Are they similar for all oceans, including the Indian Ocean and Arabian Sea?
Yes, so the wave velocity, so you mean the ocean currents. Of course, all the tools in situ can be used in all the world. So if you want to monitor the velocity of the current along the coast, better to use the radar. So there are instruments that are placed along the coast and can measure the horizontal velocity up to in a radius of around 200 kilometers. If you want to measure the velocity in the ocean, in the deep ocean, you can use the mooring. So you place the mooring on bottom of the ocean, and you along a cable you have the sensor that is called ADCP, Acoustic Doppler Current Profile, and it measures the horizontal velocity, so U and V. The gliders are able to measure the to compute the geostrophic velocity. If you want to know the vertical velocity, that's a little bit tricky. You can retrieve, for example, from glider, so the W, the vertical velocity that shows you if the water is going up or down compared to horizontal velocity. But basically, the in situ instrument is the ADCP, Acoustic Doppler Current Profile, that can be mounted on glider, on an Argo float, or a mooring, or you just go on a ship and you have the ADCP along the a rosette, a CTD rosette.
Okay. Okay, thank you. And next question. It's for Chiara. Can we visualize using automatically updated real-time data and connect it to Copernicus database, or we can only do time series in limited time frame?
Yeah, I mean, I guess perhaps this is maybe more of a question for the Copernicus Marine Service platform itself. I don't know if, yeah, either of you have updated ideas on, yeah, how, if people can pull automatically from the database.
Okay. I don't know if Leila, you can add something or?
Yes. Sorry, I didn't read the question. Using yes, you can do that. you can use a product, a near real-time product, and connect it to the Copernicus marine database. I'm not sure I really understand the question though, but well, come talk to me in the user support widget. It should be at the bottom of the page on the right, and we will answer your question. Sorry.
Okay. Okay, but then maybe we will ask this question for you, Chiara. So this is for sure for you. Have you identified another topic related to ocean you like to represent on the map?
Yeah, definitely. I think probably my next one would be exploring more of like the white ocean variables. So I really wanted to make one using sea ice extent, and I think that might be really interesting for climate storytelling right now.
Yeah. Okay, thank you. Next question is for Annunziata. What if institute data and Copernicus data are not correlated? How to decide which one to use? And well, I'm having issues with colorful data. So I guess it's more like, yeah, the two first two parts of a question. Yeah.
Yeah, there is not a correct answer. I mean, as a person, a scientist that uses in situ data, I will say I trust in situ data because are measured, but it's not always like that. So you have to be sure that, for example, your sensor is it's better calibrated, because it can happen that it's not calibrated and then your in situ data are not correct compared to Copernicus data. So first check your sensor. If you know the area, you have to correlate. For example, you're talking about chlorophyll data, the chlorophyll data of the same area, for example, from different period. So if the one you measure, let's say in 2024, is completely different from Copernicus data, probably they're not well processed data. Can be not well collected data. So there is not an answer. Usually they are correlated, especially at the surface. You're talking about chlorophyll at the surface. So I'm a bit skeptical if they're not correlated. So check your sensor, check your area, and if there is a strange behavior, it means that your in situ data are not correct.
Okay, thank you. The next question is for Leila. How is the analysis data is validated? Is there documentation updates? What measurements are input into the model, and how can we find out more?
The data are validated by comparing them with the actual observations. So there is documentation on that. If you go on the product page, you will see that you have the access to the PUME, product user manual, and to the QUID. So you will find these information in these two documents.
Okay, thank you. Next question for Chiara. As a freelance cartographer, what type of organizations have mostly used your services?
Yeah, I think thus far my freelance cartography career has been mainly focused on data providers and also academic institutions that are trying to communicate their research findings. But I'd also love to expand in many different ways, like scientific institutions or yeah, like perhaps even books or atlases or something like this as well. So I'm quite open to what that looks like.
Okay, cool. Cool. Well, books and atlases sounds very cool. Next question, and I think it would be a question for Annunziata. Could one compare Rossby waves in the Mediterranean by comparing, I assume, to area dynamics such as hurricanes, cyclones, tornadoes, dust devils?
Probably there was a confusion. The Rossby waves I was talking about in my presentation were marine Rossby waves, so in the ocean. But we have also Rossby waves in the atmosphere, which are much longer and larger. So the answer, I would say no, because the Rossby waves, they, yes, shape the weather. They tells you if you have, the Rossby waves in the atmosphere shape the weather. That tells you if you have a low pressure system, high pressure system, that the hurricanes, the cyclones are driven by a combination of different factors. So if you have strong wind, Coriolis, and a low pressure, really low pressure system. So no, the answer is no, they're completely different.
Yeah, okay. I guess the person wanted to say if they are correlated, you know, like if Rossby waves you study and such phenomena as hurricanes, cyclones, if they are connected. I think that was.
If they're connected, no, not at all.
Okay,
no.
Exactly. Okay, thank you. Next question is for Chiara. Do you focus more on static visuals, interactive products, or real-time dashboards?
Yeah, I'd say that my specialty is mainly in static visuals, although I've also gotten more into animated mapping, but it's still closer to a static visual than it is an interactive product. And yeah, a lot of that I can do in QGIS or with animation software afterwards.
Okay, thank you. Next question is Turgan. Is it possible to use AI to alter or process data? I guess we always have a question regarding AI, so.
Yes, it is possible. On Python, you have plenty of libraries to process, to use machine learning to filter or alter the data. I encourage you to have a look at the libraries called scikit-learn, for example. They are the very basic libraries. So I don't know what you want to do exactly with AI, but yes, it is possible.
Okay, thank you. Okay, a question, I think it's for Leila. Is there an option besides existing APIs to stream subsets of a data store, which would provide the fluency when using the front-end tools like Viewer?
So there are various methods you can use to download our data. So there is the subsetter, the file browser, the toolbox. You can download data and visualize them directly on the MyOcean viewer. So there is an article that's explain everything. So it is called How to Download the Copernicus Marine Products. But I'm not sure I understand the last part of your question, which would provide a fluency when using the front-end tools viewer. So maybe come chat to me and we will discuss the situation.
Okay, great, thank you. Another question to Chiara. What kind of data is most important for creating maps on phytoplankton? And could you recommend any document that would help about process of how this process works?
Yeah, I mean, hopefully I'm understanding this, but yeah, I think the most important data is the global ocean biogeochemistry variables that they have in Copernicus Ocean, which is what I used for my map, which I think we can also probably link afterwards if anyone wants to use that. I also have a tutorial online on YouTube that we can also link that goes through Jupyter notebooks of how I downloaded this, how I processed it, and how I decided which time period to use and how to visualize that. So hopefully that answers your question on how I process this phytoplankton data.
Okay, thank you. We still have some time. So there's another question for Annunziata. What CLR product from CMAMS could I use as input for a wave model like WW3, other models, knowing that my bathymetry data are relative to MSL? I guess that's a very personal question right now.
Yeah, it's a person. I'm not a modeler myself, so I'm not sure, but I will say the absolute dynamic topography and not the SSH. So
okay,
I recommend this one.
Yeah, that's quite precise question. Okay, then the next one, is there documentation describing the exact computation method used to obtain the wave variables? And I need wave instantaneous velocity data. So I guess it's for Leila.
Yes. So as I said it before, you can check the products Pume and Quid. And if you don't find your answers in these documents, you can contact the user support.
Okay, yeah, thank you. We have another question. Apart from oceans, the lakes and big dams affect the livelihoods in many African societies. Do Copernicus have data on major lakes, big dams, especially in Africa? I guess that's also for Leila.
So we don't have data for the lakes, but maybe you can try checking on the Wikio platform. I think they do have this type of data, but I'm not 100% sure. So
yeah, if I might add, yes, on the Wikio platform there is data like this, yeah, for lakes. But yeah, well, it also depending on a place, like on the continent, and well, I think there should be some information. But yeah, it's true that well, it's already land data, not marine data. So okay, I think that was it, and we are out of time for the Q&A session. So I guess if there are questions left, but there are not many left, almost nothing. So yeah, we will include them in a post-event report. So yeah, don't worry about that. And we can conclude our session. Well, as we mentioned before, on the main website of this webinar, there are a lot of information. As well as replays and polls. So for replays, replay of this session is available at the end of the day, and you also can have your certificate of attendance there. And of course, polls in the Q&A tab, you have polls. We will very appreciate if you can go there and participate. It will give us more insights on what you think about this webinar and this format. It will be very helpful for us. And well, thanks for joining us, of course. And this was the last session of this series of Copernicus Green Surveys, but it's not the last webinar we are organizing. The next series are Wikio Essential series, which is going to be, of course, all dedicated to Wikio platform. So yeah, we invite you to participate, invite you to see it. It's going to be in May, in 13th of May, 20 and 27th of May. And more information is, of course, on the website dedicated to Wikio Essentials webinar series as well. So yeah, thank you very much for your participation. Thank you very much for your questions, and of course to our speakers for their presentations and their answers.
Yeah, thank you everyone, and we hope to see you in May on the Wikio webinar series. Bye.
Bye-bye.
Bye-bye.
Bye.